Welcome to Cloud AIOps Hub, the channel where we break down complex platform engineering and AI operations concepts into real-world analogies that anyone can understand. I am your host, and today we are diving into one of the most misunderstood topics in DevOps, GitHub Actions and automated deployments. By the end of this video, you will understand exactly how GitHub Actions works, how it connects to your AWS infrastructure, and why it represents a fundamental shift in how modern teams deliver software. Let us get started. You know, this quote, it really hits home. I've seen it so many times. A team says, oh yeah, we do CICD, and they've got automated builds, automated tests, which is awesome, don't get me wrong. But then you look closer, and that last critical mile, getting the code actually live, that still involves someone, manually SSHing into a server and running a script. It's this illusion of automation. So today, we're going to tear that down. We're going to architect a system that is truly end-to-end automated. From the moment you merge your code all the way to a running app with zero human touch. Okay, so to really wrap our heads around all the moving parts here, let's forget about the tech for just a minute. I want you to imagine you have this incredibly diligent personal assistant. Their one job is to handle all your important deliveries. We're going to use this simple story to build a mental model for our entire cloud setup and our deployment pipeline. Stick with me, it'll all make sense. So, first things first. Your house, it isn't just sitting out on some public street for anyone to walk up to. No, it's inside a secure, private, gated community. In the tech world, that's our virtual private cloud, or VPC in AWS. Think of it as your own private slice of the cloud, completely walled off and isolated from everyone else. This is our foundational layer of security. And of course, inside that gated community is your house. It's the destination, right? It's where the delivery needs to end up. In our technical architecture, the house is our EC2 instance. It's the virtual server in the cloud where our application is actually going to live and do its thing. Okay, so how do deliveries even get into this community? Well, there's only one way in and one way out, the main gate. That's our internet gateway. And standing at that gate, you've got a security guard. This guard has a map, a directory. They know exactly where everything is. That's our route table. Its job is to look at incoming traffic and say, you're going to that house, and points it in the right direction. Now, just because you get past the main gate doesn't mean you can just waltz into any house, right? Of course not. There's a lock on the front door. That is our security group. It's basically a virtual firewall for our EC2 instance, and it's super strict. It says exactly which doors or ports are unlocked. For our setup, we're only unlocking two: the web traffic door, port 80, and a special door for our assistant, port 22. Okay, here's the really important part. Our assistant needs a way to get inside the house to drop off the delivery, but we're not going to give them a password, and we definitely don't want them calling us every 5 minutes for access. So what do? We give them a spare key, a special, unique key. In our world, that's an SSH key. And they don't just carry it around in their pocket, they store it in an incredibly secure, high-tech lockbox. That lockbox is GitHub Secrets. This whole setup allows for trusted, automated access without any manual intervention. All right, so that's our story. Pretty straightforward, right? Now let's get technical. We're going to map every single piece of that analogy directly to the real components in AWS and GitHub. Let's see how it lines up. And here it is, laid out side by side. You can see just how perfectly this analogy fits. Our gated community, that's the AWS VPC. The house where our app lives, that's our EC2 instance. The main gate and the security guard become the internet gateway and the route table. And that super important front door lock is our security group. And then the stars of the show, our diligent assistant is the GitHub Actions runner, the spare key is the SSH key pair, and that secure lockbox is, of course, GitHub Secrets. It makes the whole complex architecture feel way more intuitive, doesn't it? But here's the magic. And this is what really separates modern platform engineering from old school ops. We don't build this gated community by clicking around in the AWS console. I mean, can you imagine? No way. The entire thing, the VPC, the instance, the firewall rules, everything is defined as code using Terraform. And why is that so powerful? Because it makes our setup perfectly repeatable, completely reliable, and it basically eliminates the chance of human error during setup. No more, oops, I forgot a step. And this is what it actually looks like. Check this out. This tiny little block of Terraform code is all it takes to create our entire virtual gated community. We just define the address space, that's the CIDR block, give it a friendly name, and that's it. Terraform handles the rest. Just think about how much clicking and manual configuration that replaces. It's declarative, it's version controlled, and it saves us from so many potential headaches. And remember our front door lock? This is the code for that, our security group. And it's just as simple. We're explicitly saying, hey, for incoming or ingress traffic, I'm only opening 2 doors. Port 22 for SSH, so our automated assistant can get in, and port 80 for HTTP, so the public can see our website. Every single other door locked and bolted by default. It's security by design. Okay, so the stage is set. Our infrastructure is built with code. It's secure, it's repeatable, and it's just sitting there, ready to go. Now let's watch the engine in action. Let's see what happens the moment our diligent assistant gets a new delivery order. This is the 9-step automated dance that happens every single time a developer merges their code. So let's walk through this step by step. First, it all kicks off when a developer merges their code into the main branch. That's the signal. Instantly, GitHub Actions spins up a brand new, clean virtual machine, a runner. The runner then uses that secure SSH key from GitHub Secrets to connect to our EC2 instance. Once it's in, it gets to work. First, cleanup. It stops the old Docker container, then it removes it completely, no leftovers. Then it pulls the latest version of our application's Docker image from the registry. With the new code ready, it starts a new container, making our updated app live on port 80 for the world to see. And finally, the runner reports back to GitHub with a success message, and we get that beautiful, satisfying green checkmark. All of this happens in seconds, automatically, without anyone lifting a finger. I really want to emphasize this. Security isn't some checkbox we tick at the end. It's baked into the very design of this system. Our security groups act as that strict firewall. The SSH keys give us secure, passwordless access. GitHub Secrets keeps our private key encrypted and safe. And maybe most importantly, this is a workflow-only process. Nobody needs to be manually SSHing into the server for deployments anymore, which drastically shrinks our attack surface. It's just a more secure way to operate. You know, when you see a system like this working, it's easy to just think, wow, that's a cool tool. But it's so much more than that. This represents a fundamental shift in how we as engineers should think about our jobs. It's really about evolving from being a manual operator to becoming a system designer. Let's just put it side by side. The old way? You're manually SSHing into a server, you're typing out Docker commands by hand, you're praying you don't make a typo or forget a step. It's reactive, it's stressful, and it's risky. The new way, the platform engineering way, is completely different. We capture all of that expert knowledge and encode it into a deploy.yaml file. The system is designed once, it's tested, and then it just runs perfectly every time. We've moved from putting out fires to designing fireproof systems. And this is really the heart of the matter. The engineer doesn't disappear in this new world. Our role gets elevated. Instead of wasting our days on repetitive, high-risk manual tasks, we get to focus on the much more interesting and valuable work, designing, building, and improving these automated systems. We become force multipliers, empowering our entire development team to ship better software, faster, and safer than ever before. All right, I know we've covered a ton of ground there, but hopefully that analogy of the assistant and the gated community really helped all the pieces click into place. So, just to make sure it all sunk in, let's do a super quick knowledge check. Okay, first one. In our big AWS analogy, what does the gated community represent? Think about it for a second. Yep, you got it. It's the virtual private cloud, our VPC, that secure, isolated network where everything lives. Question number 2. Where should we store super sensitive stuff, like the SSH private key, in this whole automated setup? Exactly. It goes into GitHub Secrets. That way it's always encrypted and never ever hard-coded in our repository. And for the last question, what's the #1 primary benefit of defining all of our infrastructure with a tool like Terraform? The big win here is that it makes our setup reliable, repeatable, and it prevents all those little manual errors that can cause huge outages when you're setting things up by hand. That is a wrap on today's episode of Cloud AIOps Hub. If this analogy helped you understand GitHub Actions and automated deployments in a new way, please like this video and subscribe to Cloud AIOps Hub for more content like this. In the next episode, we will cover Amazon RDS PostgreSQL, explained like renting a fully managed apartment versus owning a house. You will never think about managed databases the same way again. See you in the next one.